Hi, I'm Navneet. I lead product and engineering for the Tanzu Kubernetes platform at VMware, and I represent VMware on the CNCF governing board. Let's go back in time a little under 16 years. The internet's biggest retailer launched something that was quite unique, EC2. Before then, the primary way people obtained resources was to buy or rent the hardware, possibly find a colo where they could have it operate. The process took, weeks at best, but often months. In the blink of an eye, the world changed. Now it was possible to get access to a computer, fully managed by someone else, by making an API call. You now could get access to computing resources in minutes, and better yet, you could get rid of it when you were done, potentially minutes later. So for the cost of a few cents, you could run an experiment, do some computation, and then walk away. Infrastructure was now self-service, API-driven, and elastic. And that's when cloud computing was really born. This new model was a quantum leap forward, and as people wrapped their heads around what they needed to make use of it at scale, suddenly they realized that they needed some way to properly manage the set of imperative things they did to configure their environments. If you're going to be spinning up computers frequently, or getting rid of them when you're not using them, you need a way to better recreate these environments and make replicas of them. That led to the rapid growth of configuration management systems, Chef, Ansible, Puppet, Salt, Terraform. These systems made it possible to manage the growing complexity of new infrastructure. These systems too were largely imperative, but they made it possible to start thinking about infrastructure as code. And then before you knew it, other clouds sprung up. Google Cloud, Microsoft Azure, Ali Cloud, DigitalOcean, Oracle Cloud. Each of these clouds brought their own somewhat unique twist on how to do cloud. While the philosophy was the same, computing as utility, each had their own spin on it. And this was a good thing. It actually led to a burst of innovation, with the best ideas quickly becoming common across all the clouds. You could now get infrastructure that was built by the second, managed databases, analytic systems that deliver the kind of performance and cost that you could only get when you were building for massively multi-tenant systems that shared resources at a massive and incredible scale. But from the user's perspective, all this goodness came at a cost. Like their namesakes, the different cloud providers were recognizable, but different. Take the idea of building a scale-out layer of compute, like a fleet of homogeneous front-end servers that you could automatically scale up and down based on demand, and that were automatically kept healthy. Amazon calls these auto-scaling groups. Google calls this concept a managed instance group. Azure calls it a VM scale set. While all these three things accomplish the same thing, they go about it in somewhat different ways. Consider, for example, how they distribute instances across failure domains, how they define and manage health checks, or even a detail like what happens when you delete a VM that happens to live in one of these groups. All this complexity would be manageable where it lived outside the application. But these were architectural building blocks. It was ingrained in the application architecture. And so your team had to be pretty well versed in the specifics of the cloud your application was built on. But what if you acquired a new company? Or in a reorganization, two teams that worked on different clouds on different applications came together? How could you build a uniform operating model across these similar but different applications and teams? In 2014, Google launched Kubernetes, an open source project that turned things on their head again. Applications no longer had to be deeply intertwined with the infrastructure. They were built on logical constructs that were layered atop the infrastructure so that you could have a proper separation of concerns. And it had another awesome trick: declarative infrastructure as code, which was actively and continuously reconciled against the actual state. So you didn't have to manage the outcome of a set of imperative actions yourself and deal with complex recovery from transient errors. You could, for the most part, fire and forget, and know that the system would constantly move in the direction of the desired state that you specified, and heal itself when something went wrong. Going back to the layer cake, the separation of concerns, Kubernetes not only introduced a better operating model, it now made it legitimately possible to think about multi-cloud operations, where applications could be written independently from the underlying cloud, but still make use of the advanced features that every individual cloud provided. For example, here's how you specify a container that has attached storage. The application layer is clean, and the cloud-specific stuff is cleanly separated. This has other benefits too, of course, even if you're using a single infrastructure provider. You could easily swap out the storage provider from EBS to, say, NFS by changing the volume definition. But your application didn't need to know about that. It just thinks in terms of the volume that it mounted at a specific path. And so your application developers can also remain, largely, blissfully unaware of these details. And all of this has spurred another wave of innovation, with Kubernetes being adopted at a breathtaking pace. In just 7 years, the vast majority of organizations, 96%, are using or experimenting with it. Kubernetes knowledge transfers easily, and only a very small number of people need to go really deep in terms of cloud specifics. The end. Or is it? Well, when you're operating at scale, it's not just individual units of compute that come and go. Your Kubernetes clusters are also, kind of, disposable. Treating them as such can make a number of day 2 operations much more repeatable and predictable. But now you're back in imperative land, trying to create clusters repeatably, thinking, wouldn't it be nice if I could just tell Kubernetes I wanted a new cluster, and it did it for me? Just like it does with containers and services and the rest? Turns out you can. Cluster API does for Kubernetes what Kubernetes did for infrastructure. It was launched in 2018 by the Kubernetes SIG cluster lifecycle. It has a declarative Kubernetes-style API for cluster management, and it has an explicit goal of separating the environment-specific state from an environment-agnostic state as much as possible, while still being able to use environment-specific functionality. It's been a great success with cloud provider support from AWS, Azure, DigitalOcean, GCP, Metal 3, vSphere, and many more. At its heart, Cluster API lets you use a management cluster to create and perform day 2 operations on the clusters where your workloads run, which it calls, unsurprisingly, workload clusters. Late last year, Cluster API also added support for 2 new alpha capabilities that I think really take this to the next level. Cluster class gives you the tools you need to define the shape of your cluster once and reuse it many times, abstracting away much of the complexity by letting you use a collection of cluster and machine templates to define the shape of a cluster that you can then stamp out many times for creating clusters that have a similar shape. Managed topologies are how you take a cluster class definition and turn it into a cluster, which not only lets you simplify cluster creation, but gives you a way to have a single control point for the entire topology. The end now? Not quite. If you're thinking about an organization that operates across multiple clouds, there are still some areas of inconsistency that it would be great to address consistently. Things like role-based access control, backup and restore, especially of clusters, policy enforcement. This is one of the problems we're most focused on at VMware because management at scale is hard, and Kubernetes and the cloud-native ecosystem have all the right building blocks. There's a lot of great work happening in this space, and here are some of the ones that are top of mind for me. Velero, which gives you the tools for data protection, data migration, and disaster recovery for your clusters. Pinniped, which is core to being able to do consistent authentication and role-based access control on Kubernetes using external identity providers. Sonobui, which lets you validate your Kubernetes configuration for things like conformance testing, workload debugging, and more. Harbor, a registry that enables you to securely and consistently manage your artifacts with capabilities like scan and sign images, policies, and role-based access control. Crossplane, which takes the Kubernetes approach and extends it to infrastructure, enabling you to drive infrastructure provisioning in a Kubernetes native way. Projects like Linkerd and Istio are making it much easier to connect Kubernetes clusters no matter where they are, and to really use the service abstraction to hide much of the infrastructure complexity. Tanzu Community Edition is the community-oriented set of experiences we're building around multi-cloud application development, up and down the stack. It's very early days here, and we're looking forward to learning from and with the community about smoothing the path for multi-cloud apps. While Kubernetes has made multi-cloud and cloud-agnostic development a reality, there's still a lot of important work to be done to make it really simple, easy, and secure. If you're interested in this space, we're investing in it heavily, and we're hiring. Check us out at tanzu.vmware.com. Thank you.